Okay, a typical student achievement distribution in a test is as shown in this distribution. Okay, this is what we call a bell curve grade chart. The distribution can be used to evaluate student performance in any examinations. So, for example, top two of 100. For example, you are given there are 100 students in the class. Top two of the students will get A for whatever mark they get. Even though the highest is 70, so she or he will get A if she or he is a top 2. Meanwhile, now the this is bottom 2 must fail, even though the mark is, for example, the lowest one is 50%. So even but since he or she is in the bottom 2, she must be failed according to this criteria. Okay, do you agree with this criteria or not? So think about it. Hi, my name is Dr. Kat. So in this lesson, you will learn about the normal distribution and you will be able to recognize features of the normal distribution. So let's start. Okay, normal distribution can be notated as n mean and the variance. So this is differ with the binomial distribution before, where we have a binomial distribution can be expressed with its trials and also the probability of success. Okay, the normal distribution has a special probability density function of the form this. So the PDF of the normal distribution is given in this form, where we can see it is the standard deviation, and this is the variance, this is the mean. Okay, and then this normal distribution has a symmetrical bell-shaped distribution about mean. So what does it mean? So it refers to the distribution like this. So it is we call it as a bell shape. Why we call it a bell shape? Because it resembles the shape of a bell. So that's why we call it as bell shape. Okay, this is a special continuous distribution. Okay, because it has a special PDF given here. And if we make a integral, the definite integral from infinity, so from infinity, right? This is infinity to infinity. When we calculate the area under the graph, it is equal to 1. So this is normal because the probability must be equal to 1 for anything to occur in the distribution. Okay, and then its mean value can be calculated. So you see here, this is the calculation of mean value or expectation value of the distribution, and the variance. Okay, the variance can be calculated with these relations, and finally the standard deviation is just the square root of the variance. So this is the feature of normal distribution. So let's go to the standardized normal distribution. Okay, so standardized normal distribution is notated as N01. So what does it mean? Before this, we have this is a mean, and this is the standard. This is a variance, right? So this is the variance. So variance equal. So it means that the standardized normal distribution is a special type of normal distribution. Okay, it's a special type of normal distribution where it has a mean of 0 and the variance and standard deviation equal to 1. So this is called the standard normal distribution. What is the feature of this standardized normal distribution? So it has a PDF form of this. Okay, so it looks similar to the normal distribution. So what's the difference? So let's compare. Okay, this one is a normal distribution, and the right side is the standardized normal distribution. Okay, so in this standardized, so you can see sigma is equal to 1. Okay, that's why we don't have this standard deviation. And then what is this? Mu is equal to 0, so we don't have mu. And then what else now? We have z. So now we have z. So that means we change something to transfer from normal distribution to the standardized normal distribution. So what is z? So z is equal to the variables minus the mean divided by the standard deviation. So we can actually transform any normal distribution where unlimited x into or mu or the mean where everywhere, we can transform it to the standardized normal distribution where the mu is centered at 0. So it makes any distribution to can be transformed to for easy calculation using standardized normal distribution. So the characteristic is repeat again. It is the standard deviation is equal to 1 and the mean value is equal to 0, so that the standard distribution becomes symmetrically distributed around mu equal to 0 at the center. Okay, so this is the characteristic of normal distribution. This is the characteristic of the standardized normal distributions. Let's look the more about it. Okay, so if we want to calculate the probability of something to occur between -1 to 1, sorry, this is wrong, this is z, so I make a mistake. For the this is for the standardized normal distribution, so we use z. Okay, we use z. So when we want to calculate the probability between -1 and 1, where actually -1 and 1 is the sigma, the standard deviation, one standard deviation to another one standard deviation. So we will calculate -1 to 1. So actually we can get 0.6893. So where is it actually? This is the area under this graph. Okay, this is equal to the standard deviation. This is for negative standard deviation. So actually, it means that everything fall in this area under graph, it has a chance of 68.63%. Okay, so and if we calculate from -2 standard deviation and 2 standard deviation, so we can calculate here. Okay, so what we get is here. The area under the graph represent 95, okay, 95.45% of probability. And if we want to calculate, for example, -1 to 1, so here, so we want to calculate here. So what we can do, okay, so what we can do is that we can have a 0 points, so we can have all of this, half of it, right, and minus by a part of it, so we can have our strategy to get area under the graph. Okay, all right, so this is the what we call the cumulative the distribution function. So it is the cumulative of the probability for the standardized normal distribution. So we can see that at the mu equal to 0, so it is half, right? So this means another, so this is approaching as z is infinity, so the cumulative approaching 1. Okay, so you can see that the probability is also, so this is calculation of the area under the graph. Okay, so you can see the probability become increasing the cumulatively. Okay, let's look to the example of the normal distribution. Okay, so let's say that you have the mean height of 471 UPSI students is 150 centimeter. So that we can have here, it is mu, the mean value, with a standard deviation of sigma 8. So this is sigma, assuming the height are distributed. That means all of the students have a variance or variety of the height. Okay, so estimate the number of students greater than 160 centimeter. So how many of them are higher than 160? So here, the distribution of the normal distribution is 188. So what we can do is that we can actually use the what we call Z table or Z value, where we use it from the standardized normal distribution. So what we want to calculate is actually for the height higher than 160, what is the probability of that? It and multiply by the number of the students. Okay, so to calculate that, we can make a strategy that everything so for example here, this is 0, and then when we calculate the Z value, what we call Z value, so Z value can be calculated. Actually, we don't need to calculate because usually we can use a table. So this is an example of table that you can get. You just input the X value, mu value, and the standard deviation. Then you can get the Z value here. So Z value 1.25 mean it is around here, So 1.25 sigma actually, yeah. Okay. All right. So when you use the calculator, you will get the probability of that to occur is 0.894 and so on. Okay, so this is about here. Okay. But you want to calculate this probability, that means you subtract 1 minus that probability, multiply by 471. So you get 49 students higher than 160 centimeter. How about if you want to calculate between 148 and 143, how many of them? So what you can write the probability of a height between 148 and 143 times that 471. That's mean how can we calculate that? So we have to transform to Z value. Okay, so what we can do is that we can get the 148 is equal to minus 0.25, so it's around here probably. Okay, so let's see, this is 0.25 negative and 0.37 is around here. So what you want to calculate is the area under this graph. Okay, the area under this graph. So since you can get the probability for this value and this value, okay, so you can just subtract them and then multiply by the number of students. So you get 115 students having the height between 148 to 153. Okay, so let's return to the teaser. Okay, so this is what we call criterion reference test and norm reference test. So this teaser actually refer to the normal distribution. So this is called norm reference test. And for criterion reference test is usually depends on the predetermined interval of the mark that you get. So this is usually we use in the university for semester-based test, and this is usually used in big exam. So for example, matriculation, SPM. So they use this. So actually they make some. They determine actually how many percent to get A, and so on. So this is called normal reference, and this is criterion reference. So sometimes it is good to have this, and sometimes it's good to have this. because for example in a some subject it is really difficult, so the top maybe get 60, so no one get A. But if we use this distribution reference, we can have someone A even though the mark is not so high. Okay, so but so it has a benefit, advantage and disadvantage, depends on the actually the administration of the examination. All right, so that's all for the this topic. um okay, wish you luck. Bye.